Hello everybody and welcome back. I think you all know what the big red circle means by this point. We're going to be doing some more hyperbolic geometry. Although you might notice something a little different. My GeoGebra toolbar has gone missing. Well, we better reconstruct some of it. Not all of it obviously, but we're going to use our straight edge and compass, our hyperbolic line, hyperbolic circle tool that we created in the past, to help recreate some of our familiar GeoGebra tools in hyperbolic geometry. Okay, so I have actually pared everything down. I just have the move command, the points, because points are points, and we don't even have inverse points anymore. We've got just the hyperbolic line and hyperbolic circle commands. These are going to be our hyperbolic straight edge and compass, and we're going to see what all we can create. Okay, turns out quite a bit. So, I don't know. Let's construct a perpendicular bisector. That seems like something worthwhile. So we're going to perpendicularly bisect these 2 points. Okay. Well, how are we going to go about doing that? The exact same way we did in Euclidean geometry with our circle and our straight edge and compass. Okay. So we're going to get a circle centered here with a point there. And then we're going to, still need the compass tool. Circle centered there with radius there. And now we have some nice intersection points. And they lie on a nice little line, so let's draw the line between them. Okay. And then we have this line perpendicularly bisects. Now, it doesn't exactly look like it because it looks like the distance from one point to this intersection point and another point to this intersection point looks a little different, but you have to remember lengths in hyperbolic geometry are a little deceiving. So there it very much doesn't look like it's splitting it, but you have to remember you're looking at it from a Euclidean perspective. And shorter distances close to the outside of the disk are the same as long distances very near the inside, very near the center. Okay. Now, as I move this around, I have seen my point. Yeah, there he drops every once in a while. It looks like it's dropping when these 2 points are on a diameter. Not just when they're on a diameter. And this is a limitation I've noticed with GeoGebra as I've been practicing some of these constructions. It has to do with well, mostly the culprit is the circular arc tool. I found that it's slightly off, and so some of these things are some of these points and lines and circles are gonna wink in and out of existence because it's temperamental. But yeah, there he keeps blinking. But the basic constructions are all still sound. It's the program we're using is a little limited and doesn't want to do a whole lot. I've seen some people take a very long time to program in GeoGebra some very exact hyperbolic geometry stuff, but I'm just showing you some basic constructions. And this is more about saying, gee, it's a perpendicular bisector, but it certainly doesn't look like it. Isn't hyperbolic geometry a little weird and fun? But it all can still be done with straight edge and compass. And remember, we used our old straight edge and compass to make our new straight edge and compass. So this is all stuff you can still do at home. And you can all do it exactly. You won't be able to move points around, but as you can see, it's moving these points around is causing the program to have a little bit of a hissy fit. So that's a perpendicular bisector. We're going to build off this one next time, talk about perpendicular lines through a point, and also just constructing the midpoint, which we already sort of have here, but we'll devote a whole video to that as well next time.